He's the man, he's the myth, he's the legend, he's the scientist with all the answers and all the questions. It's time for another episode of Alex's Science Corner.
Thank you.
I almost forgot to clap there.
I like how you do that in a circle.
Yeah, I give him a round of applause.
Now I get it.
It's a round of applause.
What's going on in the wild?
All right, so I'm going to be talking two stories about
I can't believe he's never
superconductors.
heard that before.
I've heard it. I just never seen it done that way.
Okay.
Okay.
Sorry. Go ahead, Ab.
I'm just giving a second so I can edit all of this out when I do the video. I'm going to be doing two stories about superconductors. I want to take a moment to talk about what a superconductor is before I talk about the two stories. First up, for electronics, there are three types of materials that are used in electronics. There are conductors, semiconductors, and insulators. Conductors are obviously wires that bring the electricity to the device. Semiconductors are the electronics inside that do the work of whatever is going to be needed to do the work for the electronics. An insulator keeps the electricity from going from where you want it to be to where you don't want it to be.
Is that also like a resistor?
No, a resistor is a semiconductor.
Oh, okay.
Resistors are part of the electronics in a device that do work. And an insulator is there to try and keep the stuff from going from one place, to keep the electricity from going
on a path.
Right, it's to keep it from going someplace.
Okay.
Whereas the conductor is where you want the electricity to go. What a superconductor is the electrons are not suffering any resistance at all. Even with a straight wire, normal wire, either copper, silver, or gold wire, when the electrons are moving down the wire, they can still bounce into the various atoms of the material, and when they bounce, they generate a little heat. So a normal wire that's just a straight wire is still generating heat. Some of the electricity is lost in the heat that is generated from the electrons moving across the wire. A superconductor is not suffering any loss for that. So all of the electrons are going straight through the superconductor to the other side of the superconductor with no loss. And it's a goal to have that because obviously if you can cut down that loss, you're going to save a lot of electricity from moving it from one place to another.
So heat loss is equivalent to energy loss.
Yes, because again, instead of the electron going through the wire, it instead hits some of the atoms in the wire and generates heat from that. So we have superconductors right now, but they have to be really, really cold. And we're not exactly sure how all the different types of superconductors that we figured out work. Now, towards that end, the U.S. Department of Energy, Ames Laboratory, and physicists at the University of Alabama in Birmingham, they have created a special type of laser called I'm going to try and read the name here because it's a pico-electron laser. And what it does is, terahertz spectroscopy laser. It takes a picture with a laser that is 1/20th of a second long. And with this, they believe they're going to be able to measure the structure of these superconductors to try and figure out how they are working. And so the fact that they've created an electron laser that fires that fast, and they've started taking pictures of superconductors to see what about the superconductor is allowing the superconductor to let atoms move through that fast. It's an interesting level of research. They've gotten this new technology that's going to hopefully help them figure out what's going on. One of the other challenges is that these things have to run at very cold temperatures, usually about 4 or 5 degree Kelvin, which is around minus 450 degrees Fahrenheit.
So these are in a special building.
Well, yeah, you have to be in a special building.
They're shielded from where all these superconductors are working.
No, it's the whole point of the laser is to look at the superconductors.
No, that's not. I mean, are they like in a separate room with a glass so that they can see?
They've created this laser that is used to test the superconductors. The idea being to try and figure out the structure of the superconductors.
Okay.
Because they think the superconductors are going into this different state of matter.
Okay.
Where they're calling it also superfluid.
Okay.
So that the electrons can go through it real fast without hitting any sort of atoms. Now, with that in mind, the second story I'm going to talk about, physicists at the Massachusetts Institute of Technology have discovered a new superconductor. What they've done is they've taken a graphite sheet, which is, it's kind of pencil lead. It's, the pencil graphite, but it's a little more single layered. Now, graphite itself is a insulator. Electricity won't cross it without extremely high voltages. So they use graphite sheeting as insulators. Well, what these physicists did is they took one layer of single layer graphite and put another layer of single layer graphite on top of it and rotated the second layer 1.1 degrees off of each other. So the atoms are almost aligned, but not exactly aligned with each other. And the space between the two sheets became a superconductor. So these two insulators with this minor adjustment became a superconductor. The fun part for them is they don't know why it's happening. They just figured that it is happening.
Kind of I'm sure they didn't stumble upon
Well, no,
it.
they were trying to do some research on graphite. And
Right,
during the
right.
process of doing the research on the graphite,
They
they
discovered
discovered
this-
this new property. They don't know why it's happening, but this is going to be the next step. And again, this is one of the things that the laser that they just discovered may be able to help figure that out.
Now, is graphite the same
It's-
element that like
It's
they
carbon.
make? Okay, but they make. There's a number of different things that they like. You can make golf clubs, graphite golf clubs.
Yeah, well,
and
graphite is from pencil lead to diamonds.
Okay.
And carbon is in pretty much
Okay.
everything except actual metals and stuff.
Okay.
Carbon is one of the more common elements other than hydrogen and oxygen, or hydrogen and helium. But graphite is pretty common. It's just that this carbon is a special form of graphite called graphene, where it has a certain special structure. And you can lay it out in a single sheet, one atom thick. The last quick note I'm going to say is, if you've gone online, you may have seen pictures from Ultima Thule from the New Horizons probe. They've got a few quick pictures. I know all the astrophysicists are really excited about that. It's going to take a couple more weeks before they get the rest of the data and all the other data that they are collecting, because it's going to take a long time to transmit. But one quick note, Brian May, who was the singer or guitarist for Queen, he's also an astrophysicist.
Yeah,
and if you go
Brian
to
here is shaking his head. Yes.
Yes,
Yeah.
he is also an astrophysicist. And if you go to the Queen official channel, he has a song about the New Horizons probe. So if you want to go online to Queen's official channel or look up Brian May and New Horizons, you can listen to the song that he wrote about the New Horizons probe.
That sounds like fun.
Is it any good? That's my question.
It sounds like a Queen song.
Okay.
The lyrics are fine, but it sounds like a Queen song with lyrics that
Maybe our
It's
Brian can find it and we can debut it on the show a little later.
Yeah, we'll take a look into that.
Yeah, see if that would.
But anyway, those are the stories for today.
Okay. If you have any questions about these stories or anything else science related, you can call Alex right now at 203
837
99
24.